Hey guys, it's Tom Cotton, and today we're going to be taking a look at the 2000 AP Calculus AB FRQ question 5. So let's get cooking. So our question today is consider the curve given by xy squared minus x cubed y equals 6. And the part A asks us to use implicit differentiation to find the derivative of that function. So first we're gonna rewrite our function, and then the first step is to take the derivative of both sides. And you're gonna keep in mind that when you take the derivative of x, that's just gonna be 1. So it'll be 1y squared plus 2y dy dx times x minus 3x squared y minus x cubed dy dx equals 0. And I apologize for the cursor left in on that screenshot, but that's just 0. So part A continued, you are going to move all the dy dx's over to the left side of the equation. And then the next thing you want to do is factor out that dy dx. So you can isolate it by division. And then we're going to divide both sides by 2yx minus x cubed. And then so you're going to get the dy dx that you were looking for initially. And yep. So on to part B. You're going to want to find all the points on the curve where the x-coordinate is 1 and write an equation for the tangent line on each of these points. So your first step is going to be to plug 1 in where x would be. And then you are just going to move down where you have y squared minus y minus 6 equals 0. And then you're going to want to factor from there. So you're going to get y minus 3 times y plus 2, which gives us our two y coordinates being 3 and negative 2. And then, as previously mentioned, the x-coordinates are going to be 1 for both of those sets. So you're going to have 1, 3 and 1, negative 2. So to find slope, we're going to plug our x and y values into the derivative equation, which we got from part A. So you see that right there. Then you're going to take the coordinates 1, 3 and substitute the 1's in for the x's and 3's in for the y's, which basically is just going to give you 9 minus 9 over 5, which is equal to 0. So that is going to be your derivative for the point 1, 3. Then you're going to want to do the same thing for your second pair of points, which would be 1, negative 2. Plug those in and then solve, and you'll get 2 as your slope. And then from there, we are going to use the point slope form to write our tangent lines, which is just going to be y minus y1 equals mx minus x1. And then if you plug those points in and using our slope, we can derive our two tangent lines, which are going to be y plus 2 equals 2x minus 1, and then y minus 3 equals 0, x minus 1, and then you move that around and just get y equals 3. On to part C, you're just going to find the x-coordinate of each point where the tangent line is vertical, and we know that the tangent line is vertical when the slope is undefined. So we're going to try to set the denominator equal to 0, and that'll be 2xy minus x cubed equals 0. Factor out an x, and that's what we get. So from there, you can deduce that x equals 0. And when you solve for y, you get y equals x squared over 2. And then going back to that initial equation in part A, plugging in the x value of 0, we can see that this equation does not equate. So 0 can obviously not be equal to 6. But however, the y function, y equals x squared over 2, also y equals 1 half x squared does work. So we can start plugging that y value into that initial equation over here. And that's what it's going to look like. We're going to start solving for x. So multiplying through. and then you're going to want to multiply both sides by 4 in an effort to simplify, and then from there you have x to the fifth minus 2x to the fifth, which is going to be equal to negative x to the fifth. You're going to divide both sides by -1 and then take the fifth root and arrive at your final answer, which is going to be fifth root of -24 equals x. And this is from the one time that Mr. Hall was late. So we have, in a nice Comic Sans font, "You're late, coach." Thanks for tuning in. Hope this video was helpful.